Right.
Okay, since they are telling me the work, and I know that the work is an integral from a to b of that guy, dx. Now, I don't know what that guy is, so I'm going to call him kx. It goes from 38 centimeters to 42. That is x equals 0 because that's its natural length, and that is x equal to, in this case, 4 centimeters, which is
Professor,
0.04. Yes.
uh, actually, this is kind of strange because I got correct on A and B, which is the process that you're explaining right now, but somehow for K value, I put like fraction as fraction, it doesn't work.
Okay, let me get the numbers and see what we get. So it's 0 to 0.04, and that's going to equal 4. Now you integrate that, you're going to get 1/2 kx squared from x equals 0 to x equals 0.04. Did you do something like that?
Yes.
Good.
Can I say something real quick?
Sure.
So when I did this one, I had to do it a few times because WebAssign, when you approximated it at a decimal, that's what I did, and I got an answer that it seemed right, but it wouldn't take it. And so I went to the practice another, and they said that you had to do it in fractional.
Yes, so we have to do this exact without rounding off. Yeah, that makes sense. Okay, so it's going to be a bit messy, but here goes. Oh, let's double both sides. That way I get rid of the half. And if you multiply 0.04, and you square it, you get 0.0016k. And so it's now going to be 8 over 0.0016 equals k. And I'm going to do that, and it's going to be 8 divided by 0.0016. And I get a nice round number that doesn't have any problems. So what did I do wrong?
Professor, actually, it says for getting K value, it says 34, natural length of 34 centimeter to 47.
Oh, well, 34 to 47. So I have to change my limits of integration. So if that's going to be 34 and that's now going to be 47, you know, it keeps changing the damn thing. So it's going to be 0 to 0.
Yeah, 0.13, right?
13 now. That's going to be 0.13. That makes that 0.13. 0.13 squared is going to be 0.0169. So k is now going to be 8 divided by 0.0169. Okay, and that guy I'm 90% sure is not going to be pretty, but let's see what he is. He's 8 divided by, or let everybody in, 0.0169, and you get that decimal, which you can't see because I haven't got enough light. And I'll hit the math button on 1, see if I can make it a fraction. And there's my fraction. Get some light on. Yeah.
Right.
So I just like the calculator, do the division, and then take that and make it a fraction. Now I should be able to do that without needing the calculator. It's a bit messier. But if you multiply that guy, you get this over 169.
Yeah, actually, it very makes sense because I just put 8 over 0.0169 in as a fraction, but it's not exactly a fraction, right?
Right. The reason that doesn't count is a true fraction isn't allowed to have decimals in it.
Right.
So you're not allowed, and a true fraction is not even allowed to have fractions in it, in the sense that you can't have a half over 7/9. That wouldn't be considered a real fraction.
All right, I see. Thank you.
Are we good?
Yeah.
Okay. It sounds to me like it the process. It was just trying to get the number, in this case, the fraction, the way that WebAssign was asking. Right. Now, I seem to have picked up a rather annoying glare from one of my lights. So let's see if I can change its position. Is that doing anything? Nothing. Okay, let me see if I can reset it. Okay, we'll do it that way. Okay. Good morning, everyone. We should get started any moment now. We've got a few people still coming in. Maggie, have you got a really corny joke to start today off?
I do.
Oh, good. Sierra, you're looking forward to this, aren't you?
Oh, so much.
Oh, the insincerity is overwhelming here. Okay, go for it, Maggie. What you got?
All right. What two premature actions should you avoid entering into?
I don't know. What two premature actions should you avoid entering into?
Marriage and embalmment.
Oh, dear. That's bad, Maggie. You got another one?
Did you hear about the 3 Norwegians who died splitting wood?
No.
They fell out of the tree.
Okay, John, are my jokes beginning to look good now? Sierra, are you beginning to regret saying you were looking forward to this?
Wait a second, but that was like so close to the Canadian raking leaves.
It is. Okay, I think that's the last. Anybody else is just late. Well, so good morning, everyone. Let's get this. Let's get started. So, job today. Okay, my goal today is to get average value functions finished, and to start the next section, which is a technique for integration that's called integration by parts. It's not as useful as USUBs are, but it still allows us to integrate functions that we can't integrate right now by the methods that we know. So let's start with this fella, version of 9. The function is 1 over t squared. It's between 1 and 2. And you're going to find there's 3 basic questions. We're going to find the average value, which we're comfortable with, I hope now. We're now going to go hunting for the C, right? So there's at least one number C, according to the mean value theorem, and it has to be in the range 1 to 2, such that the value of the function at C is the same as the average value. And here's the big clue, 3 decimal places. So the minute they ask for an answer as decimal places, you can pretty much be sure that you're just going to do it through decimals. And they got this little funny thing called a sketch, which I'll tell you about when we get to it. So you want to find the average value. It's going to be the integral from a to b of our function, and 1 over b minus a. Almost forgot it, but technically it's there. But isn't that 1, so it's not going to make any difference, because 1 over 1 is 1. Are you happy about this being turned into a negative power so we can use the power rule? So it's going to be add 1 to the power, divide by the new power, from t equals 1 to t equals 2. I'm going to rewrite it for calculation purposes and for style point purposes like that. And what do we get? We get negative 1/2 take away negative 1. And that came out, I believe, to being 1/2. So that's question A. Find the average value of that function. Now we're being asked to find C, right? So finding a coordinate in the range 1 to 2 that has the value, the property that the value of its function is the same as average. So we're essentially trying to solve when is the function equal to half. And that one is actually so simple that I could have actually done it algebraically. But since they told me they want the answer to be to 3 decimal places, I'm going to use Desmos. So I'm getting Desmos set up right now. Right, are you looking at Desmos? Okay, so what you basically do is you type in y equals 1 over x squared, and then y equals, in this case, a half. And sometimes you have to take it around a little bit, move it up and down. There we go. If I click on there, that guy there, you see him? That is 1.414. We have now found our C. 1.414. There is another place over here called negative 4.14, right? The x coordinate. I guess you'd call it a t coordinate in this question. But I'm not going to use that one. Why am I not going to use the negative 1.414 as the other choice?
Because it's not in the interval.
It's not in the interval. Now, sometimes you will have two values. So like both of them could work in a different story, right? When that happens, what you do is, I think they call it a comma separated list. Have you ever had one of those awkward things? Basically type in the first one, comma, type in the second one. Right, so that's what you would do. And now I'll return back to the whiteboard, and we'll show you how to do this funny little diagram that they're on about. What they do is they give you, I think, the usual 4 pictures. And it looks something like this. I'll do it over here. That's what 1 over x looks like. Can we pretend that x starts at 1 and there's t, and I'm calling it x, it's actually t, right? That's that guy. And that the fellow we're talking about is about here. And you draw a line, something like this. And that's the picture that they want you to do. They want you to do the start and finish of the interval, and they want you to make the rectangle the height of whatever C is. And there'll be like 4 pictures, but only one of them will look like that. So if you look at them and you think, what the heck is going on? You're looking for a start at 1 and a finish at 2, and the height to be whatever the average value is. And I've just said 1.414, and I am wrong. It's half. That guy there is a 1.414. So start at 1, finish at 2, and the height of the average value, which is half. We cool with that one? Any questions? Does it seem reasonably straightforward? Okay, don't have any. Right, here's one that's going to cause you trouble. Let's do the average value of this fella. It's going to be 1 over b minus a. The integral from 0 to pi of f of x. I'm going to split this thing into 2 pieces. Okay, there's the first guy. Looks like this. I could have brought the 4 out, I just didn't bother. And here's this one. Brought out the 2, and while I was at it, I brought out the negative and got this. Are you comfortable that this is the same as that? Right, that these 2 guys are equivalent to that top guy. Now, the reason why I'm doing that is because each piece is going to be treated differently, and it just is easier if you separate them. Right, this one's pretty straightforward. If you take 4 sine x and you find its antiderivative, it's negative 4 cosine x. And that becomes negative 4 cosine pi, take away negative 4 cosine 0. Cosine pi is negative 1, so negative 4 times negative 1 is 4. Cosine of that is 1, add another 4. So this piece has a value of 8 over pi. And this was done basically just a normal kind of integral, nothing too special. Okay, this is the awkward one. How am I going to integrate the sine of 2x? How am I going to integrate the sine of 2x?
Could you start by changing that to 2 sine x cosine x?
I could do that, and what would happen after that? It's a good start. Yeah, that would work. What would you do next?
Then I would try to find the antiderivatives of those 2.
No, that the second bit's not a good, such a good as first. Once you got it to 2 sine x cosine x, you could do u sub on it.
Oh, okay.
You're not allowed to find the antiderivative of a product by finding the antiderivative of the 2 bits and just multiplying them. Actually, it would be really nice if you could do that, because it would make a lot of questions much easier than unfortunately they are. But yeah, you could do it that way. I'm going to do a u sub, but a little different. What u sub could I do with this question?
2x.
Yeah. So when I differentiate it with respect to x, I get 2. And I do the crossover, I get that. And then I divide both sides by 2 to isolate the dx. Right, do you see that's going to come out a little bit nicer, isn't it? Let's see what we get. We've got an integral of the sine of u times 1/2 du. And they cancel out, so you get that. And you're going to then get the integral of a sine is a negative cosine of u. And that becomes negative cosine of 2x evaluated at 0 and at pi. And if you put in pi, you get negative cosine of 2 pi. Take away the negative cosine of 2 zeros. Cosine of 2 pi is actually the same thing as a cosine of 0, so they essentially cancel out and you get a big fat nothing. So your answer is that guy. Are we okay with that strategy? Now we could have done Harrison's. If we did, wouldn't we call this 2 sine x cosine x and maybe do a u sub of sine x? And eventually you would have ended up with the same answer. Are we good? Now, part B, find the C. So we want to find some guy is equal to that? Well, we're trying to find a value of x that has this property. Would you agree there's no way in the world that's going to be done algebraically? So what we have to do is we have to use Desmos. So it should be interesting. Okay, there we go. So I'm going to return back to Desmos. I'm going to put in that function and that one, and we're going to see what we get. So it's going to be 4 sine x. That won't be, get rid of that first. There's 4 sine x. And take away 2 sine 2x. Get that guy. And the value we're looking for is 8 over pi. Can't remember, is it just pi? Yes, it is, just pi, good. We're only interested in 0 to pi, which is essentially 0 to here, right? So when we look at this fella, can you see that the guys I'm wanting are those two here and here? Right? So from 0 to pi, which is about here, that's 0, that's pi. I want this guy and I want this guy. So it's going to be 1.238. And the other choice that I could have is 2.808. Now I'll return. And this time I need one of those comma separated lists. So my answer would look something like that. And the picture, well, you have a sketch of this, starting at 0, finishing at pi, and you make sure that the height of it is roughly 8 over pi, and one of the pictures falls into that category. Move that maybe too quickly. Is there anything about question 11 you'd like me to talk about? Are we okay with 11? So that means yes. Okay. Now this one's a different puzzle. Find all the numbers b such that the average value of this function on the interval 0 to b is equal to 7. Never done one like this before. We're not being asked to find the average value, we're told it at 7. We're being asked to find what this guy is. How do you think I might tackle that question? Just in a big picture way, I don't need the details, but how would I solve this problem?
You could solve for the indefinite interval and then solve for 7.
Sounds like a good idea. So we know that's 7, so we're going to solve that for 7. And we know it goes from 0 to b, so we'll do that. And we've got our function. So we're going to get essentially an indefinite integral, as I said. So what's that? 6x, 5x squared. You get, oops, take away 2x cubed. And evaluated at 0 to b. And we get 6b plus 5b squared, take away 2b cubed, minus a whole load of nothings. And we're now at that point, yeah. Great. Now, does that look to you like it's something you probably would do with Desmos? So go to Desmos, type in 6x plus 5x squared, take away 2x cubed, and do that guy. And whichever values cross is going to be your answer. So that was essentially, most of that's done.
What about the 1 divided by b minus 0?
You are right. Oh, I do not. Do you see that 1 over b basically reduces this down by a power? That means that I don't need to do Desmos because I need to solve this equation. So if I add 2b squared to both sides, take away 5b from both sides, and take away a 6 from both sides, I get that guy. Quick check in case it factors. Nah, no such luck. Make that A, make that B, make that C. And so the solution will be negative B plus or minus the B squared, take away 4AC. Let's check if I needed that. You do. They don't want a decimal. That means we do have to find the solution as an exact value. Do you recognize that formula? You didn't think you were going to use the quadratic formula anytime soon, didn't you? And you probably won't for a long time again, but you need to know it for the situation that's going on here. And I know that's a bit awkward calling this B, but that's the variable. So it's 5 plus or minus negative 5 squared, take away 4 times 2 times 1, all over 2 times 2, which is 4. So it's 5 plus or minus 25 take away 8. 25 take away 8 is 17. And so your two answers will look like 5 take away root 17 over 4 and 5 plus root 17 over 4. And since both of these are positive numbers, both of them count. We good? Well caught. Forgot my 1 over b minus a. Last question. Nice ugly one to finish with. Oh, I've forgotten to write down what the limits of integration were. In a certain set, the temperature in Fahrenheit tiers after 9 AM was modeled by this function. And so they want us to do it from 0 to 12. Okay, so that's the interval. And all we're being asked to find is the average value, in this case, the average temperature. So it's 1 over 12 take away 0, the integral from 0 to 12 of this function. We talked about this guy yesterday, didn't we? And we said, look, what method would you use to integrate this ugly looking function? If I recollect, it was a u-sub, wasn't it? Can anybody recall what the u-sub would have to be? What was the u-sub for this function?
Would it
Pi
be
t over-
pi t over 12?
Or if it helps, you could write it like that. It's the same thing. When you differentiate it with respect to t, you just get a number. When you do the crossover, you get pi du. No, you don't. You get 12 du equals pi dt. And when you divide both sides by pi to isolate the dt, you get that. So that's the guy that's going to go there. So we have 1 over 12, the integral of 56 plus 56 sine of u, and 12 over pi du. I'm going to bring this guy out and suck it with that fella, and the 12s cancel out, and so you get 1 over pi. And I'm just doing that to try and make it a little bit neater. That's about all. So it's going to be 56, take away 15 sine of u's, and 15 take away cosine of u's. That's going to be 56 u, take away 15 cosine of u, evaluated at 0 and at 12. It's going to be 56 times pi times 12 over 12. Take away 15 cosine pi times 12 over 12. Take away nothing and minus 15 cosine zeros. They cancel and you get 56 pi. What does this guy give you? It gives you negative 15 cosine of pi, negative 15 negative ones, it gives you plus 15. And what does this guy give you? Check my signs here. Gives you, it's like another 15. Check this one. Yeah. And so it looks like I get 56 pi plus 30 over pi. If I made a mistake there, it's just in calculations. Looks a bit ugly. I thought it would be nicer than that. I was hoping that those two would disappear and you just get 56, but evidently I was wrong. Okay, so we are finished with average value of a function. So we're moving on to our next question, or next topic, and that is going to be called integration by parts. I'm trying to find what the number is because I can't remember. It is a new chapter. Oh. We have finished chapter 6. We're doing a new chapter, chapter 7, in particular chapter 7.1, and it's going to be called integration by parts. Okay, so what's this about? Chapter 7, for the most part, is going to be finding or showing you techniques for integrating special situations. The two main techniques that we use are, and I'm grouping them together, power rule and memory. Right? Power rule is for x cubed plus 5x squared and the square root of x. Right? Use the power rule, does a lot of integration. The one I'm calling memory is, you know that the antiderivative of e to the x is e to the x, and you know that 1 over 1 minus x squared is inverse sine of x, right? Things you just memorized. That's one chunk. After that chunk, I would say even more importantly was u-subs. Aren't u-subs really good at finding integrals of really difficult things? Integration by parts is going to allow us to find these two kinds of integrals. The first kind is integrals that are products. So we're basically going to be looking at integrals that are made up of two things multiplied together. Kind of like the product rule for differentiation. Remember with the rule for differentiating f times g. Integration by parts in many ways takes that job. It allows us to find the integral of two things multiplied. And second job for integration by parts it allows us to find the integral of unusual single integrals. For instance, we'll be able to find that guy. We'll be able to find the integral of that guy. Now you might say, oh, well, we already know that one. And if you think the answer to that is 1 over x, you've got your wrong cap on. Isn't the derivative of log 1 over x? But what's the integral of log? We don't know yet. I know what the derivative of inverse sine x is. It's 1 over the square root of 1 minus x squared. But what is the integral of it? That's not the same thing, right? So this is a pretty useful technique, right? It's not as useful, in my opinion, as the u-sub technique, right? The u-sub technique gets you out of all sorts of holes. But there are some situations where u-sub doesn't work, right? And that's why we need this technique. Now, there are two techniques or two ways of doing integration by parts. I don't know if any of you have ever done integration by parts, either from high school or maybe you did it in some other place, maybe another professor, and you may have used the UDV method. And I am not going to do that. I'm going to use this method. The integral of f of x, g of x, dx, right? The integral of that product is f of x, capital G of x, take away the integral of f dashed of x, capital G of x, dx. This fella is a formula, but it's not in the usual way you'd expect a formula to work. Normally you expect a formula is you plug stuff in, you do what the formula says, and you've got the answer. In this formula, you plug stuff in, but what you end up with is another integral. This integral here, right? So it's not that you make the integral go away, you just change it into a different integral. But that integral there is easy to do, or will eventually be easy to do, and then you do it. So it tends to involve more than one stage. So let me show you an example of it working. I would like to do the indefinite integral 3x e to the x. Well, let's talk about what you can't do. Would you agree it's not a u-sub? Wouldn't it have to be 3x e to the x squared? And then it would be a u-sub, and that's actually how I would do it. But it's not. e to the x squared, doesn't it? Just the e to the x. So the techniques that you've got today, you cannot integrate that, right? You don't know yet, but it can work with this fella. Now, I should mention something here. Where capital G of x is the antiderivative of little g of x. I think that's kind of obvious, isn't it? We use the notation that capital just means integral. I've not enough room. Do I need to write down f dashed of x means the derivative of f? I think you can figure that out, right? So I won't write it down. So here's the guy we're going to do. I'll actually put it over here on a new piece of paper. And we'll go through the shortened list of the typical way to do these questions. So step one, identify who f of x and g of x are. Now, you might think, does it really matter? Yes, it does, in many questions. If you don't pick the right f and the right g, instead of this thing making the answer to this bit easier, it gets worse, right? So in this case, I have to choose who f and g are going to be. There are rules about how you choose f and g. I think the first part is, would you agree that it's pretty obvious who the two pieces are? It's just who do you make the f and who do you make the g is the choice. So you could just do the, I'll pick one at random, and if it don't work, I know it's the other one, and that eventually will work. Or you can use some rules I'm going to tell you. These rules are not as good as the U sub rules because there are many exceptions to them. But in general, if you ever have a power of x, 3x, x cubed, 5x squared, followed by an e to the anything, right? You're going to make this the f and this is a g. So tend to make the x's, the x squared, the x cubes, right? The polynomial piece, the f of x. And that's your rule. Make the polynomial guy your f of x. And that will get you by, I know, 80, 90% of the situations that works fine. And then there's exceptions, which we'll see when they turn up, where you kind of have to change the rule. Basically, they switch places. So this fella is going to be 3x. And this guy's going to be e to the x. Step one done. Step two, apply the formula. Well, let's see what that looks like. Right, there, fella. It's going, I guess I should put this down. It's going to be f of x, capital G of x, take away the integral of f dashed x, capital G of x, dx. F of x is 3x. The integral of e to the x is e to the x. Take away integral. Derivative of this guy is 3. Integral of this guy, e to the x, dx. Do you see that this integral has now become this one? Step 3. Continue process until you get the answer. Okay. Would you agree that the integral of 3e to the x is something we can do? We don't need any special process for that. So I'll continue my process. And what do we get? We get that guy with our C, and we are finished. So we now have a way of integrating 3x e to the x. Now, continue the process until you get the answer really didn't happen here because we were pretty much finished because this integral was doable. So let's try another one, a little bit uglier. Let's try that one. I'll show you the working that I typically do, especially when they get difficult. This one's not difficult yet, but it will. Would you be comfortable with 5x squared being the f and sine x being the g? Would you agree this is a pretty standard two to pick story? So this is going to be 5x squared. This is going to be sine x. I normally, especially in the ugly ones, write down what the derivatives are or the integral as well. Right. So we can now move on to, that's step one done. We can now move on to step two. So the integral of f of x, g of x, which is basically that guy, is f of x, capital G of x, take away f dashed of x, capital G of x, dx. I'm going to put it over here, I need the room. F of x is this guy. Capital G of x is this guy. Take away, derivative is 10x. Capital G of x is negative cosine x dx. In this line I'm about to do, I'm just tidying things up a little bit. Are you comfortable with me just taking care of the two negatives and making a plus and rearranging that? Oh, do you see that the integral that's left over isn't one that we can just get the answer to? What do you think we're going to do here?
Do it again.
Yeah. There's another technique that you met in Calc 1 where you do that. Wasn't there situations where you had to do L'Hopital twice or maybe even 3 times before you got your answer? You remember that? So it's not that uncommon that you've got a process, and this is really a process as well, that you have to apply more than once. So that's where step 3 comes in. Continue the process until you've got an answer. So I've got negative 5x squared cosine x plus this fella. Now in this one, are you happy with this being f and this being g? So we are going to do f of x, capital G of x, take away f dashed of x, capital G of x, dx. There's going to be 10x. Integrate that guy, you're going to get sine x. Take away. Differentiate this guy, get 10. Integrate that guy, you get sine x dx. You happy with that line? Make that more subtraction. Is it 10 sine x something we can get the answer to? So we're going to be stopped in a few seconds. So it's negative 5x squared cosine x plus 10x sine x. And if you integrate 10 sine x, you get negative 10 cosine x's. So you get a plus 10 cosine x's. Where's C added on it there? let's look at how clever that process is. If I asked you, yesterday to integrate that, you'd pretty much be stuck, wouldn't you? You wouldn't be able to figure out how to do it because you don't have the process. When you look at what the answer is, do you notice that the answer is quite ugly? If you just had to guess and check, would you agree you're probably not going to guess that? So it really would be impossible, practically speaking anyway, for you to just get lucky and predict what the antiderivative, the integral is. Do you like integration by parts? It's okay. I like it a lot. But when you compare it against what your strategy would have to be, that's a big deal. Right. I'm going to talk about, just for a few seconds, a little trick of the trade that's going to make our job quicker. You are going to have to integrate things like this. There's a good chance that it won't be e to the x, it'll be e to the 3x. It won't be cosine x, it'll be cosine 4x. E to the 3x is e to the 3x with a third. That guy is sine of 4x with a quarter. Can you remember the linear shortcut method? What that means is I can integrate these guys in my head without having to do a u sub of 3x and go through the whole u sub process. Would you agree the u sub process can be quite lengthy, especially when it's a very simple looking function, right? So if you want to find the e to the 3x sine or cosine of 4x, right? Anything with just a 2, 3, 4, 5x or even a half x in it. Can you just remember this little trick? Right, it's called the linear shortcut method. Let's check it out. What would be the antiderivative of e to the 5x based on this shortcut method? E to the 5x, what would it be?
1/5 e to the 5x.
Do you agree that's a lot quicker than going through the u sub process? What would the cosine, and be careful here, because I'm deliberately picking an ugly one. What would the integral of the cosine of negative a half x get you?
-2 sine of -1/2 x.
You all happy about the negative a half giving you -2? 5 gets you a fifth, 3 gets you a third, a half gets you 2. So negative half gets you -2. That little trick can save you a good couple of minutes every time it happens. So I suggest that you get comfortable with it. If that really is something you just don't want to handle, you can always do it using u subs, but you're probably going to have to have lots of scratch paper around to do that. So that is us.